Next problem, a agricultural experiment was conducted on Latin square to investigate the yields per acre of 5 different varieties of wheat when subjects to treatments of 2 types of fertilizers A and B, each of 5 different strengths. The results are set out in a Latin square below, in which letters correspond to the varieties. Column are treated with different strength of fertilizers A and rows with different strengths of fertilizers B. Right? They have given. So discuss the yield variation with respect to each of the factors. Total number of items n is equal to 25. So number of column, number of row, that is equal to n, that is equal to 5. Null hypothesis, there is no significant difference between column. Row, there is no significant difference, and letters, there is no significant difference. So alternate hypothesis, there is significant difference between column, row and treatment. So shift the data to origin 15. So you will get new data. So subtract 15 from each and every numbers given in the above data. So first A 16 minus 15 1, 10 minus 15, right? First row I am talking about, right? 10 minus 15 minus 5, and 11 minus 15 minus 4, 9 minus 15 minus 6, 9 minus 15 minus 6, like that, etc., etc. The last one be 14 minus 15 minus 1. Next calculation for ANOVA. So row R1, R2, R3, R5, and column C1, C2, C3, C4, C5. Write the revised data here, right, from the previous column, right? Then first find the row total. So add the row numbers. First row numbers 5 minus 1 0 minus 2 minus 2 0. Second one 1 4 1 0. Similarly for the column, add the numbers in the first column. 5 minus 1 4 plus 1 plus 2. So 11 minus 11 1 minus 4 9. Adding the numbers row total or column total, both should be same. So you will get grand total G is equal to 6. Next to find Ri square by n. So first one 0 square by 5 0. Second row 1 square by 4 0 0.20. Third one 3.2 0.24 20. Fourth one, and last row 0. Similarly for column, so just add the total, so summation Ri square by n. So take the total of that particular column, you will get 3.6. Similarly go to column Cj square by n. First 11 square by 5, first column 24.2. Similarly minus 11 square by 5 sorry, 24.2. So third column 1 square by 5 0.20, then fourth column 3.2, and fifth column 16.2. So sum up all those things, summation Cj square by n 68. Next row sum of squares. So square each number in the first row and add 5 square minus 1 square 0 square minus 2 square plus minus 2 square 34. For the second row 15, third row 84, fourth row 35, fifth row 30. Similarly for the column squares, right? So square the numbers in each numbers in the first column and add up 5 square minus 1 square plus 4 square plus 1 square plus 2 square 47, 39, 23. Similarly for each and every column 63. So you will get the grand sum of squares, right? Add either a row total or column total sum of square. You will get double summation xij square, that is equal to 198, right? Next correction factor g square by n minus 4 square by 16, that is equal to 1. Next you find the letter sum of square, that is for treatment LSS. So alphabetical order A B C D E. If it is a number, you write 1 2 3 4 5 6 in the order, right? Ascending order. So 1 2 3 4 5. So you write the corresponding numbers with respect to the letters in the brackets in the previous table, right? So A5, A next to A 0, then 3, then 2, then A. Then similarly take the numbers nearby the alphabet B in the previous table, right? So write it in the order. First B, second B, third B, fourth, fifth. Similarly for C, right? Take it from the previous table and write it in the order, right? Without missing, right? Then first to find the row total, that is L1. So row total, first row L1, second row L2, L3, L4, right? So adding all the numbers in the first row, 5 plus 0 plus 3 plus 2 plus 7, 17, 9, 0, minus 5, minus 15. Then find the summation, next find Li square by N, right? N is equal to 4, 5 here, right? Not 4, 5, right? So 57.8, 16.2, 0, 5, 45. So total summation Li square by 4, that is 5, that is equal to 124. So total sum of square, so 996.56 from the previous table. Column sum of square 66.56, row sum of square 2.16, letter sum of square, this is from this table, right? Above table, table 2, 122.56, error sum of square, that is equal to 5.28. Then prepare the ANOVA table. Source of variation, column, row, letters, that is treatment and error or residual. Sum of squares, you write it, right? We have calculated previously. So take it from that. And degrees of freedom, V1, n minus 1, V2, 4, V3, 4, and V4, n minus 1 into n minus 2, 12. Then mean sum of square column. So using the formula CSS by V1, so 16.64, MRSS 0.54, MLSS 30.64, MESS 0.44. Then F ratio FC, that is 37.81, FR is 1.227 and FL is 69.64, right? So whenever you are writing F ratio, keep it in your mind that you have to write always the greatest number in the numerator comparing with MESS. So if you are taking ratio for column FC, so check MCSS, mean squares column, right? MCSS and MESS, check the values. So here MCSS is 16.64 and MESS is 0.44, which is greater. MCSS is greater, so write MCSS always the numerator and the lowest one in the denominator. Then you find the ratio, right? Similarly for all the ratio FR, FL, right? Then conclusion for column degrees of freedom V1, V4, right? So from the table calculated value is tabulated value is 3.26, and when you are writing the degrees of freedom, don't change that, right? So you have to write within the bracket, square bracket. So pair number V1 comma V4, whenever you are writing V1 comma V4 or V4 comma V1, check the values. MCS numerator is the first one, right? In the FC, whenever you, that is the greatest one, right? When comparing MCSS and MESS, MCSS is greater, so first write V1 then V4, V1 comma V4. Suppose MESS is greater than MCSS in some other problem, you write it V4 comma V1. So then based on that only you have to identify the tabulated value from the table, right? F table, otherwise it will be a wrong one, right? So comparing FC and FT, so FC is greater than FT, so H1, H0, 1 is rejected. Row, similarly for the row 4 comma 12, so comparing FR is less than FT, so null hypothesis H0 2 is accepted. Then treatment, comparing FT and FL, so FL is greater than FT, therefore null hypothesis H0 3 is rejected. Thanks.